All right, so glial cells, let's talk about them and what they may have to do with autoimmune disease, multiple sclerosis, chronic fatigue, and aging. Um, Glial cells, basically glia is a Latin term for glue, because at some point in the past, when we learned about the anatomy of the brain, we recognized that there are brain cells, nerve cells, otherwise known as neurons, and that they are interposed by these other cells, which were felt to have the role of gluing the different parts of the brain together. As we became more and more sophisticated, we realized that no, these are actual cells that are doing something much more sophisticated than gluing things together, that they were actually providing nutrients to the brain cells. Later on, we found out that they're actually also providing immune function, so they're acting a little bit like the soldiers of the brain to try to keep things clean and in order. And then we later on found out that they also have some of their own projections and connect to these different networks of brain cells by things that kind of look like axons and synapses. And then most recently, we've discovered how they are so close to the B cells of the peripheral immune system. So that in the circulation in our bodies, we have B cells and T cells and macrophages and killer cells, and these guys help to keep things in order. But apparently, they also traverse back and forth between the brain and can subsist in the brain and perhaps even become glia cells themselves. There is some potential back and forth between the peripheral and the central immune system. However, these glia cells, as a result, can be affected by what happens in the body in a couple of different ways. Number one is that some of the infected B cells with CMV, Epstein-Barr, and whatever other pathogens may be involved can gain entry into the brain and continue to produce the same antibodies that they did in the rest of your body. In addition, if you have an infected cell and the autoimmune theory about how unresolved Epstein-Barr can lead to autoimmune disease can also explain why the B cells can either make antibodies or make EBNA1 in the brain that subsequently the glial cells respond to, and this can lead to illness and inflammation in the brain. And this is really not that much theory, because these B cells have already been isolated in the brain of people with multiple sclerosis. So the question isn't so much whether this is true or not. I think it is true. The question is, what can you do about it?